Good morning, students. So today we are going to start a few more properties of transition elements. Now, next property of transition elements is colored ions formation. So if we see transition elements, then most of the transition elements, they form colored ions. Now see here in the picture you can see that different colorful stones are there which we use in our wings and all. So this thing is because of the presence of small quantity of d block metal ions. Now see these colorful substances which we are able to see, these gemstones, this is because of the reason that there is presence of some d block metal ion. Okay, because of that this is the color. Okay, now see most of the d block elements, they form colored compounds. Now why do they form colored compounds? Because there is presence of incompletely filled d orbitals. So what does it mean? It means that there is presence of unpaired electron in d orbital when we talk about transition elements. Okay, now see what is the phenomena involved that we can check. When an electron from a lower energy d orbital is excited to a higher energy d orbital, the energy of excitation corresponds to the frequency of light absorbed. Now see what we are saying, that when there is a substance which absorbs certain light, so because of that absorption it gets excited from lower energy level to higher energy level. Okay, now this frequency lies in the visible region. Okay, now what we observe, the color observed corresponds to the complementary color of light absorbed. Means whichever light is absorbed by the substance, there is one complementary color of the absorbed substance. That complementary color is seen by us. Okay, so there is a chart which shows us that if this color is absorbed, then which color will be seen. Okay, there is a chart that will come ahead, so there you can better understand. So what is the phenomena involved? A substance absorbs visible light of certain wavelength, okay, and it transmits or reflects visible light of other wavelength. Okay, so whichever is emitted or reflected or transmitted, that is called complementary color. Because of that it appears colorful. Okay, so which colors are shown, this we can see. We have to see that in the electronic configuration there must be presence of unpaired electron. If there is presence of unpaired electron, then only there will be some color. Now see, if there is absence of unpaired electron, in case of 3d0 there is absence of color, unpaired electron, so these ions will not show any color, they will be colorless. But when there is presence of unpaired electron, then they will definitely show certain color. Okay, so what question is asked? Why transition metals show colorful, are colored in nature? This way you can ask. So what we have to see, we have to write down the electronic configuration of the element and then for the ion. And if there is presence of unpaired electron, then we will say that this ion is colorful. If there is absence of unpaired electron, then we will say there is absence, this particular ion will not show any color or it is colorless. Now see, we have taken few examples. You can see the colors. If CO2 positive is present in aqueous form, then its color is like this. Zinc is present, then the color is like this. If ferric ion is present in aqueous solution, then it is the color. Okay, so there are few more. Manganese ion shows like this color, ferrous ion shows this color, copper ion shows this color. This you know, copper sulfate solution you have seen many times. Now see, this is the chart. This if you can remember, that will be wonderful. See, if blue light is absorbed by a substance, then what color we will see? We will see yellow color. Okay, blue light absorbed appears yellow, and if yellow light is absorbed, then how it will look like? It will look blue. Okay, so this is the chart of complementary color. How we can remember? See, if blue is there, then yellow will be there. If cyan is absorbed, then it will appear red. If magenta color is absorbed, then it will look green. If violet color is absorbed, then it will look greenish yellow. Okay, so if we remember this chart, then it will be quite helpful that if this is the light absorbed by a substance, then how it will look like. Okay, now the next property is formation of complex compounds. Now complex compounds are given one more name, that is called coordination compound. Okay, so complex compounds are those in which the metal ion binds a number of anions or neutral molecules, giving complex species. Now see, just like this is the example, this is one of the example. Now here what is there? This is central metal atom. Fe is the central metal atom which is bonded to 6 CN groups. Okay, and when 6 CN groups are attached, these are cyanide ions like this, Cn negative. These ions are attached with iron, then overall charge on this species becomes 3 negative. Now this form is called complex or coordination compound. Now the question arises, transition metals form complexes, why? So now see, if you look at these examples, how bonding is formed. This central atom is bonded to 6 CN groups. 6 CN groups means in the octahedral form it will be arranged like this. Okay, now which type of bonds are formed in this? This type of bonds are called coordinate bonds. So there is formation of coordinate bonds. So 6 coordinate bonds are formed by 6 Cn negative ions with iron. Okay, now if central atom has tendency, it has capacity that it can form 6 bonds with 6 Cn negative groups, then only it can form complex. Okay, so what we are going to say, we will say that the central atom possesses this ability. Why it possesses this ability? Because there is presence of vacant d orbital which can accommodate the lone pair given by groups which are going to get attached with this. So Cn negative, what Cn negative will do? It will release a lone pair, and that pair will be bonded with the central atom by the coordinate bond. Okay, now central atom must have the vacant d orbital where it can accommodate this pair of electron. So since it has the capacity to absorb, to accommodate the lone pairs, so it can easily form coordinate bonds, and so the compound formed will be termed as coordination compound. Okay, now what we can say now, we will say that transition metals possesses vacant orbitals in d orbital. So accommodation of the lone pairs donated by the ligands, these are called ligands, just like Cn negative is called ligand, they can be easily accommodated, so it is easier for them to make coordination compounds. Okay, now next is catalytic properties. Now we are asked question like this, that transition metals are used as catalysts. Why? You might have seen so many processes where we will use catalyst, and that catalyst will be belonging to D block. Okay, now see here, if we see contact process, then we are using vanadium oxide. If we take this Haber process, then we are using iron. If we take catalytic hydrogenation, then nickel is used. Similarly, there are so many reactions where we are using the transition metals. Now question comes, why do they behave as catalyst? Okay, now what catalyst does? Catalyst at a solid surface involve the formation of bonds between reactant molecules and atoms of the surface of the catalyst. Okay, So what is the purpose or what is the role of catalyst? It involves the formation of bonds between the reactant molecules and the atoms of the surface of catalyst. So what happens when we use a substance as catalyst? Then it provides extra surface for reactants to get attached with each other. Okay. Now what it does when it allows them to combine, this has the effect of increasing the concentration of reactants at the catalyst surface and also weakening of the bonds of the reacting molecules. Now see, what is the effect of catalyst here? What catalyst will do? It will provide the surface area, and now reactants can attach with that, and when they get attached, then old bonds will start breaking easily. Okay, so in any reaction there is breaking of old bonds and formation of new bonds. So it helps in the breaking down of old bonds. Okay. Now this particular transition metals, they have one more property, that they can change their oxidation state. They show variable oxidation states. So because of this capability also, they are very much useful as catalyst. Okay. Now let us see a few examples. If we talk about contact process, then this is the catalyst used. If we talk about Haber's process, then iron is the catalyst used. If we talk about conversion of vegetable oil into banaspati ghee, then there is use of nickel. If we talk about formation of nitric acid, then there is use of platinum as catalyst. So in all processes, when we talk, when we discuss, when we see, then we find that transition metals are involved as catalyst. Okay. Now an important property comes, formation of interstitial compounds. Now first of all, what are interstitial compounds? Now before that, we have to study what is interstitial site. Now see, here if you see the diagram, in this diagram, whatever space is left out between the spheres of atoms after packing, that place is called interstitial void or interstitial site. Okay. Now when we are saying that it is interstitial compound, then it means that small sized atoms will occupy the space. Which space they will occupy? Which is present as vacant space inside the solid. So if such thing happens, then the new compound formed will be termed as interstitial compound. Okay. So what we want to say, that if we see the structures, the crystal lattices of transition metals, then there is enough space between the spheres where small sized atoms can be easily accommodated, just like hydrogen, carbon or nitrogen, they can be easily accommodated, and then the resulting substance formed will be termed as interstitial compound. Okay. So what question comes? Question is asked like this, that transition metals form interstitial compounds. Why? So what we have to say? We will say that in case of transition metals, there is presence of interstitial voids, and the size of interstitial voids is large enough to accommodate small sized atoms. So when we accommodate small sized atoms in those interstitial sites, then it results in the formation of interstitial compounds. Okay. Just like this is titanium carbide, this is manganese nitride, this is combination of iron and hydrogen, vanadium and hydrogen, titanium and hydrogen. Now see, here you can see one thing. Here I have written VH 0.56. Now what does it mean? It means that if I am having 100 molecules, 100 atoms of V, then there will be 56 atoms of hydrogen. This means like this. Okay. Their ratio is like that. Here what we mean, if I am having 100 atoms of titanium, then there will be 170 atoms of hydrogen. Okay. This is the meaning. So in terms of ratio, it is written like that. Okay. Now when there is formation of interstitial compound, then what happens? These are the properties which are seen in interstitial compounds. Okay. They will have high melting point, Then the pure metal, they will be very hard, okay, and they will retain metallic conductivity, and they are chemically inert. Okay, so these will be the properties which we can see in the interstitial compounds. Now see, just like here, suppose there is one important example, it is called tungsten carbide. It is called tungsten carbide. So what is there? W, this may be W, green one, and this may be carbon. So when carbon atom gets trapped in the interstitial voids of the crystal lattice of tungsten, then there is formation of an interstitial compound which is called tungsten carbide. Okay, so this way it is formed. Okay, now one more property is alloy formation. Okay, now see, it is asked like this, that transition metals form alloys. Why? Now what is an alloy? An alloy is a blend of metals prepared by mixing the components. Alloys may be homogeneous solid solutions in which the atoms of one metal are distributed randomly across the atoms of other. Such alloys are formed by atoms with metallic radii that are within about 15% of each other. Because of similar radii and other characteristics of transition metals, alloys are readily formed by these metals. The alloys so formed are hard and have often very high melting points. Okay, now see what is said over here. See, it is said that what is an alloy? Alloy is a mixture of two or more metals, or a metal and a non-metal, like that. Okay, now how the intermixing will be smooth? It will be proper, it will be feasible. It is only possible when a particular atom replaces the other atom from its crystal lattice. Now when it can happen? It can only happen when the sizes of the atoms are comparable. So what we can say? We can say that transition metals, if we see, then their sizes are not very much different. They are almost same, means that there is not large difference in the sizes of transition metals. So they can easily replace one another in the crystal lattice. Okay, so they can easily form alloys. Okay, now there are so many alloys like this. These metals, they form alloys. Okay, non-transition metals also, they form alloys. Just like brass is an alloy of copper and zinc, bronze is an alloy of copper and tin. Okay, so there are so many alloys possible. Okay, now in this diagram you can see this is pure metal, where we can see the presence of constituent particles of the metal in a proper way. Now when any other element we add in this, any other element when we add, then the atoms of that element replace some of the atoms from this crystal lattice, and they form like this, and this is substitution. So we can say it is a substitutional alloy. Okay, now it may also happen that the substance which is added is very small in size, and that may occupy interstitial sites. So if it happens, then we will say it is interstitial alloy. Okay, now this is also possible. Then we are mixing three things. One is of very small size, another one is of comparable size. So substitution and interstitial, both things will take place, and that will be termed as substitutional interstitial alloy. Okay, so these are the different ways in which alloys can be formed. In general, we can say like this, that some other metal has replaced the atoms in the crystal lattice of first metal. Now see, we are mixing suppose M and M dash. So what will happen? M dash atoms will replace M atoms from their crystal lattice, and then there will be formation of symmetrical homogeneous mixture, and that will be termed as alloy. Okay, so these are the different properties which we discussed. Now on the basis of these properties, you have to solve these home assignments. Okay, thank you.